everyone. Welcome to the Motivational Talk section of the CMSYC job matching event for 2022. So today we're joined by Dr. Loukas, who's a research staff at CERN. So today he'll talk all about his journey as to how he got to where he is today, and will also give advice to early career researchers.
Thank you very much, Catherine. Thank you very much for the kind introduction and also the invitation. And I'm very happy to share my experience since the start of my career in physics. So why we are here, actually? So I think this event is mainly for PhD students and early career researchers, postdocs who either, for example, look the next job in academia, like PhDs that they want to find a postdoc position, or postdocs that they are going after a tenure track position. And the idea is there to get feedback from various people at probably later stages in their career in order to shape their the plan of action, where to put focus, etc. So you get input, then you shape your, you adapt at your needs. So the other thing is actually for those that are not sure if staying in academia is the right fit for them. So there are pros and cons staying in academia against private sector. So I'm trying to highlight some differences as I see them. Also, maybe there is another third group of people that are curious how is life outside physics. So here I can only share the feedback and from colleagues and friends that made this transition. So take it with a grain of salt. And there is a big disclaimer here. So today I'm giving you my perspective and share examples from my journey here, right? So this is mainly based on personal experience and discussion and mentorship from my supervisors, colleagues, and friends. And I'll do my best to be as unbiased as possible. But clearly there are many other angles, different stories, different experience. So I think rule zero is actually to listen to people and shape your future. And the last thing is actually the slides here are meant to set the scene and spark the discussion. So I'm pretty happy if you interrupt during the talk and ask questions during the talk. Okay, so how I entered the game. So I had multiple inputs, but I think the moment that actually triggered me most, it was a present from my father, actually. This is in Greek and means actually Einstein for beginners. Of course, if you go to page 2, here is the present was back in 1994. So I was in primary school at the time, so I couldn't understand things inside the book. But I found actually very fascinating that what we do as physicists is we are trying to explain how nature works. And I think that was one of the, let's say, the most important inputs I had to follow a career in physics. So, and now going to more concrete examples. So I did my bachelor and also my master studies in Athens, University of Athens. This started before the start of the LHC. And this period I focused solely on detector development. I was working on the development of a small subsystem of CMS, the castor calorimeter. Is a very forward detector conceived to search for exotic physics, heavy ion physics, etc. So during these years, I was focusing on developing simulation for different design concepts, participating in test beams and analyzing the data, and also the commissioning of the subsystem at 0.5. There is, I mean, working on the detector and on hardware in general is very critical for the success of the experiment. If you don't have a detector, you don't take data, so you cannot do analysis. Clearly, the challenges are very different with respect to analysis work. And I think, actually, looking back, actually, this is a very essential ingredient for your CV. I mean, this makes you, it's an important the part of your CV, and this translates to successful job applications. Now, moving, the challenge here, of course, is actually I faced, like when I was a young physicist, growing physicist that work in a big collaboration, that we have very many smart and knowledge colleagues around, and it can get overwhelming. So the big challenge was to lose the motivation and don't lose your courage and your optimism. So I think one advice here is actually to take time the time necessary to learn things in depth, and don't be afraid to ask questions. And of course, everybody, you know, we do mistakes, we fail sometimes, this is fine, as long as we learn from them. And at least what I did is actually when I didn't do something the best way possible, I use this as extra motivation to work harder and prove that actually I can deliver. And probably, you know, this guy here is arguably the best basketball player. And long story short is he succeeded because he did many mistakes and learned from the mistakes. So this was one of also paradigm. I used to play also basketball when I was younger. Now, moving on my PhD, I still did it in Athens, but I was actually based at CERN. So I transitioned completely from detector development and hardware to doing solely physics analysis. My focus was in the search for supersymmetric signals. The start of my PhD coincided with or included the part of the LHC run one. So it was a really high time to search for SUSY signals, both inclusive scenarios, but later, given the null results, also for natural SUSY. This is clearly a different world, different challenges, require different skills. Also, there are many groups that pursuing the same physics channel, so one has to learn to collaborate, and it was not always very smooth, but this is things that one has to learn. And then the other part actually that I was focused during my PhD is to get involved in the object reconstruction. And particularly I focused on the reconstruction of missing transverse energy or momentum, which is actually a key observable for the searches for SUSY, right? So in a few bullet points, as a PhD, how I see it is actually you want to showcase that you can do research, right? And see actually how it's like doing research, if you like it or not, right? Because this will be important for the next stage of your career. For instance, if you want to stay in academia or go, for instance, to industry. Then concerning your thesis, this is your thesis, so you have to be proud of it. So you need to choose a topic that you find intriguing. You want to explore your ideas, but sometimes, you know, you want to prove you are capable of doing research, but here is a fine line here. You have to be careful. You should aim for evolutions, small solid steps, rather than revolutions. So try to improve a step at a time. At least this is what I figured out that was a work for me. When I try to do big steps, usually was not a very smart idea. And the last thing, but important, is, as you know, most people know that you're going to reach your limits. You know, you have to work around the clock. Things don't work out at the first time you try them. So you need to be patient. And the key is actually not to lose your target and your interest. You always remember why you are doing this, why you're doing your PhD, why we're doing physics. Now later, after completing my PhD, I moved to Santa Barbara for my postdoc. So there I continue my physics analysis, starting with searches for supersymmetry, particularly for top quarks. But then I'm extending my interest also in measuring the Higgs properties, particularly in measuring the Higgs charm coupling. And if, you know, I think a critical point in my career was actually that after the first round of SUSY searching, I took a step back and I thought, you know, what will be important for the community, for the field, in order to open up more windows, research windows. And this was actually to focus on developing jet tagging, jet identification algorithms, particularly with the deployment of machine learning techniques. So this was a bit of a risk, because instead of having another round of SUSY searches, you know, I decided to take a step back and focus on these new tools. At the end of the day, I think it paid off. Now, a small fraction of my time was working on focusing on the far, far future, and particularly for in concepts related to the 100 eV collider, the FCCE, towards the conceptual design report that we had at that time. Now, a few points. So as I see it, as a postdoc, you have already proven that you can do research. You have your PhD, right? The next step is to become a leader. So for this, you have to coordinate a group of students in the university, potentially also a group in the experiment. I was, for instance, a convener in the MET group. You also need to bring new ideas and new direction in the group, get roles of responsibility in the experiment, and also you need to actually take stock of the tools, of the analysis that you are developing. And bear in mind that actually, as a postdoc, this is the stage that actually is the last step before getting a permanent position, either in academia or in outside the field. So people have to recognize your quality and your skills. And then since 2019, I joined the CERN group, first as a research fellow, and then as a staff physicist at CERN. So here I continue doing most of my time focusing on physics analysis in the Higgs and di-Higgs sectors, continue my involvement in the object reconstruction, focusing on jet identification. And I also joined here the CMS phase 2 upgrades, initially focusing on the reconstruction, the particle shower reconstruction. At that time, it was high time because we were writing the HLT technical design report, and this was a key. The reconstruction using the HG calorimeter was a key point. Recently, the last year or so, I joined also, I went back to the more like on the detector and the hardware side, joining efforts with groups in the lab. And I still keep a small fraction of my time focusing on the far future, not so far as the 100 TeV collider, but still far away in the A plus and minus, FCC plus and minus. So if I can summarize my career up to now in physics, it's kind of interplay between detector development, physics object reconstruction, physics analysis, and a bit of a far future. And at this stage, I would like, unless you have questions, I would like to share a few tips and a few lessons that I learned through these years. So I think it's very important to develop as a scientist, both in terms of depth, but also in breadth, right? So if you have a well-rounded profile, it also gives you allows you to identify the priorities of the field, engage with high-profile, high-important physics topics, have vision, etc. And at the end, all this comes to enjoy science, right? Because if you do something that it's important for the field and gets recognition, then you also, you're happier. At least this is how I see it. And then on the practical side, of course, having a well-balanced profile actually improve your chances to get a tenure position if you want to stay in academia. One of the big challenges I faced actually was to learn to complete things. Clearly it's more fun, if you conceive a new idea, let's say you have a new variable or a new analysis approach, etc. So this is exciting. Then you say, okay, let's see if it works. Then you prove that it has potential and that it works. So this is exciting. But then, of course, we all know that putting it actually going to the end product from conception, proof of principle, final result, takes a lot of time. And this sometimes probably is less exciting, it can be tedious. But, as here I have the sketch, you know what you want to achieve, you know you want your paper to write, but you have to actually write it, you have to calculate the systematics, etc. But this is what at the end matters, the public result, the paper, physics analysis summary. So there one has to, maybe potentially play some mind games to keep focus and carry out all the necessary steps in a timely fashion. But an important point here is actually in which detail you want to study things, right? There is a trade-off between precision versus effort and time you put. For instance, like, when I was searching for SUSY, right? And usually we search for SUSY in the tails of the missing transverse distribution. So we're talking about very few background events, 2, 3, 4, less than 10 events. So the statistical uncertainty that we have, it's 100 times, it has 100%, right? So of course, it doesn't make sense to develop a background estimation strategy that aims at the percent precision because it's not relevant. So there is things that one has, and this optimization strategy, it comes with experience. But this is an important point to take care of. A few more tips. I think it's also very important to plan and think strategically. This is more difficult at the beginning because there are so many things to learn and to gain experience, but it gets easier with experience. And the reason I'm saying this is, instead of having a Brownian move, bouncing around several projects, etc. So I have a sketch here. So, you start from this point, you do a lot of walking around, a lot of effort, but the outcome, we end up here. The outcome is very little. Imagine you have huge HT, right? But what matters if you do, for instance, SUSY search is the MHT, the vectorial sum. So you want the vectorial sum. You want to start here and end here. You want the vectorial sum to be your effort to have important outcome. So so I would suggest actually to identify a few topics with high physics impact and get stock of your achievements. And recruiters, as I see it at least, they know that you can execute things. You have a master's degree, you have a PhD, but what make you stand from the other application is your vision and your potential to expand the scope of the group. Another thing that I think is important, also discussing with my supervisors and my mentors, is that you need slope matters. You need to have progress, to show progress versus time in here. The fireworks are not very welcome. So you have to show consistency. Clearly, this is not very easy. Our field is very demanding, it's very challenging, it's very competitive. But I think this is also another key for success. And what helped me keep focus, at least most of the time, because it's not always easy, first of all, is actually not forget the reasons why I entered the field, why I'm doing this, why I'm doing physics. Also, the fact I find fascinating that we are developing a very versatile skill set that are useful both in academia and the private sector. We have keys that can open multiple doors. And also, extremely interesting, I find extremely interesting that we are actually on the top of the developments in multiple fronts, not only in terms of physics, but also in terms of computing, in terms of analysis techniques, like data analysis techniques, programming language, etc. And I think I find all these things very interesting, that I try actually to think when I feel like I'm losing focus, to keep me on the line. Now, of course, it's very important to keep a balance between work and life. I'm not going to lie, it's not, we have to work a lot, and there have been periods that we work flat out, work around the clock, work weekends, right? It's not, usually people say it's Friday and, they're happy, they're going to relax. Most of the time, this is not the case for us. So my advice would be actually, when there are periods, calmer periods, try to clear your mind, work hard, but also you can, have a hobby, hang out, etc. And also one of my mentors actually said that a tired mind makes mistakes, right? So you have to identify when you are really tired, and you have to take a step back in order to avoid silly mistakes. The other part that I think it's also important, and I came to realize, is actually how you're giving talks. So I think one should consider every talk that they give as a job interview, right? And there are two main fundamental rules. Rule I put 0A is actually practice, and practice the talk before you give them. So it can be tedious, it can be boring, it takes time, but certainly pays off. And for me, it's a no-brainer. You have to practice very, very, very well the talks you are giving. The second equally important rule is actually to never include a plot or an equation or a statement in your talk that you are not fully sure what is showing, or what are the underlying details. It's very bad to get a question concerning a plot and don't be sure what is actually the plot saying. So you need to be on top of things. And actually, this is important because it gives you confidence. So when you present, you are confident, you know what you are saying, and this is evident to the audience. And remember, people that are following your talks are potentially recruiters, right? Can be a professor at the university, part of a search committee. The other part is how you engage when you follow talk. You have to ask questions, engage in the discussions. And they are beyond the clear advantages that actually you have a question and get an answer, so you broaden your physics knowledge. It's actually you get to know people. And potentially, you can even join forces with other colleagues on an exciting new project. You can also build connections. Some of these people could be your letter writers, for instance, in a job application. So engage in the discussions, follow actively talks. And the last thing I want to discuss here is actually about teaching. So certainly, if you are a postdoc at a university, it's easier to get some teaching experience than in the lab. But I think there are ways actually even being in a lab to get experience in teaching. And I think a very important point here is actually science moves by transferring the knowledge we get. So I think it's our duty actually to not miss opportunity to share our knowledge. And of course, actually, it's essential. I find this is essential. Teaching is essential for our full development as a scientist. Now, here I'm moving to the last part of my talk, which is about the next stage in our careers about concerning the job application. There is a big dilemma actually to stay in academia or move to industry or the private sector. And clearly there is no good or bad choice. There is no wrong or correct answer here. I think the correct answer is actually to do what suits best for you and what makes you happier, because this is why we're doing things, right? We want to be happy and enjoy and feel proud of what we are doing. So concerning academia, then there is also a dilemma if one goes to a lab or to a university. The advantages in general of academia is that security. If you get a tenure, the position is very, very secure. In the lab, you must align with the priorities of the lab, of course. But in the case of a university, you are much more independent, particularly if you get a tenure position. In a university, a significant fraction of the time goes to teaching. I mean, actually, it's a responsibility. If you are a professor, you must teach, and you must teach well. And also writing grant proposals. So this means that you probably have less time on hands-on work on research. In contrast, in a lab, working in a lab, you are more engaged with the developments, you are more attached to, more hands-on on, for instance, in an analysis, developing an analysis. There are little to no teaching duties. You can do teaching, but it's not mandatory. Less time on writing proposals, etc. And also, at least at CERN, it's harder to recruit students and postdocs, right? We don't have, in principle, it's not a university, so we don't recruit students and postdocs. Concerning the industry and the private sector, again, this is mainly from feedback I get from colleagues and friends that made the transition. Of course, tenure is much less secure. I mean, people usually change jobs, etc. The working hours are much more normal than in academia. There can be different topics of focus, right? There can be a period, shorter or longer period, that you may work on a project, let's say, related to self-driving cars. Then another period could be like to find a way to provide and improve medicine, etc. This is not so frequent in academia. And last, but probably it's an important also matter, is that the salary it's much higher in the private sector compared to the majority of the jobs in academia. So, of course, there is, it's a fact that the positions in academia are getting fewer and fewer than what we had in the past, and this is a challenge. So many colleagues transition to industry, and here I have a plot that shows actually the employment for colleagues that obtained the PhD in 2000, where they are. So around 60%, almost 60%, are in other fields than physics than where they obtained their PhD. So it's engineering, computing software, business and finance, etc. There's only 1/5 of the, and this is actually the green line, the green marker here, is 1/5 of those that obtain the PhD in physics. They continue with a tenure position in the same subfield of physics, and then another 1/5 actually still in physics but in a different subfield. And here, as I said about the salaries, for instance, there is, working in the private sector has significantly higher salary compared to postdocs, for instance, or working at university, etc. So, and last thing is actually, I have not heard a single person that regrets making the transition to industry. This doesn't mean that I'm trying to bias you to move to industry. As I'm saying, and I want to highlight and say that this is not the end of the world, actually. And don't be afraid. Actually, we have the skills, we have developed the skill set that can make us successful also in different fields. And here you have, for example, which are the main actually knowledge that is used in different positions, like in physics, engineering, computer science. The most important one is solving technical problems. This is what we do in academia. Programming, this is also what we do. Design and development of new ideas, techniques, methods. This is what we do in physics, engineering, computing science. And then, of course, basic physics principles, just the fourth, for instance, in computer science, more important in engineering, depending on the topics. So, and a last word about the job applications is, I think it's independently of if you are applying for a job in academia or a job in the industry, you must tailor the application material to the job. It's very, I think it's very useful, extremely useful actually, to contact directly the recruiter. You have to learn about the job. You have to learn what they're looking for. And will also help you tailor the application material. Prepare extremely well for the interview. First of all, having so many candidates reaching the interview stage, this is already a success. So congratulations for this. Then after this, one has to prepare a very nice, very exciting story to tell, highlight the challenges and how one managed to solve them. And think about it as an opportunity to showcase your skills. Also, you have to demonstrate innovative thinking. And remember, people that they want to hire, the recruiters, they want to hire people that can think out of the box, and they are able to expand their program at the university, in a lab, in a company. And also, last but not least, actually, you should ask questions. So you have to see, they ask questions to you. They want to see if you fit in the group, but you also have to ask questions. You also have to see if you can fit in the group and you have interest aligned with the priorities of the group, of the company, of the lab. And always keep in mind that getting a job is a process. It may require a few turns. This is normal. It's not, if you get like a rejection letter, it's clearly you're not happy, but you should not get disappointed. It's a process. Actually, getting a job is an actual job. So I think that's all I wanted to show today. And I think it's time for discussion. I'm happy to take questions. And of course, if you want to chat further on these topics, feel free to reach me. This is my email here. Thank you.